Awesome. Well, hi, friends. So I'm Greg, and I'm the factotum at Opsy. A little bit about me, because I'm sure some people are like, who the hell is this guy? Why is he up here? So I started working as a sysadmin at an internet service provider in around 1999, doing technical support, system administration, et cetera. I've done a little bit of everything, all the way through ops to research in artificial intelligence to singing with the Atlanta Opera to working on CRUD, ETL pipelines, that kind of stuff. So a little bit about what I do. I'm engineer number 1 at Opsy, and I basically try to lead a team of engineers to build a monitoring product. Quick blurb about Opsy, just so you kind of understand like what we're trying to build and a frame of mind for what we're trying to do there. So Opsy's a managed intelligent monitoring service for AWS. We assist and facilitate check creation and remediation through things like service discovery and continuous monitoring of all of your AWS assets. So you start up in AMI, and ta-da, you have monitoring. So what does a first engineer do anyway, and why in the world is my title factotum? Factotum literally means do all the things. I was hired more or less to do everything, but most importantly, as engineer number 1, I feel like it was my job basically to say, let's go from proof of concept to minimum viable product. So, yeah. So I knew that if we were going to do this, I would need like some infrastructure, right? We'd need something to build on, to iterate on quickly. And so let's at least get something quick and dirty, even if it's not like the best ever. So I don't like to just sort of dive into whatever I'm doing. So I practice a thing called the FFPR loop, which is pronounced just in case you were wondering. It's very important. And it means fiddle, fail, process, rebuild. So I start to do something, and because everyone makes it look super simple in all of their blog posts, I like bash my head against it in frustration, because in reality it's incredibly difficult, right? This is, why we have jobs. And I get ready to rage quit, which is hence, and then, I kind of calm down after that and then take a deep breath and slowly exhale, hence. So yeah. But really, this is just Bloom's taxonomy of the cognitive domain. So this has been a teaching implement for like the last 60 years or so. And it's a system of thinking that divides everything up into 6 stages or types of learning. And that's knowledge, comprehension, analysis, application, synthesis, and evaluation. So knowledge. We start by thinking, okay, well, what tools do we know about, and where are we? So let's build a knowledge base from which to work. And that's my knowledge cat. She's awesome. So first we start by asking, where are we? So we were running the well-known infrastructure pattern known as AS, which is an AWS instance with screen and then a service running in screen, right? Everybody's done this before. So yeah, we've all done it. It's fine. It's fine. Everything's fine. So what we need to understand, though, is like, okay, well, how did we get here? Like, really, why do we do this? What are its strengths and weaknesses? So it's super simple, right? Like everybody can start up an AWS instance, SSHN, run screen, and then, like java-jar, whatever. So, that's great. Anyone can do it. We only had a single monolith, so we didn't really need anything fancy, and the only reason we were running it in the first place was so that our front-end developer had an API to hit. So we didn't have a product yet or customers, which is, the luxury of startup land. So why do we need more than this, and why do we need it right now? And it seems like a silly question, right? It's like, well, why do we need more than screen? It's fine. So you have to kind of ask yourself why, right? So we were getting ready to hire a couple more engineers, deploy like 5 more services, and go from deploying, once every 2 weeks to like 20 times a day. And deploys were this, right? You SCP your jar across, you SSH, you reattach to the screen session, hit Control-C to kill your service, hit up arrow, and then hit Enter to restart it. Bash history as deployment mechanism. It's fine, everything's fine. So, if you're deploying once or twice, a week or every other week, this is gonna be okay for now. So the next step, application, is where you ask yourself the question, so if we're not gonna do this anymore, what are we gonna do? What tools do we have that allow us to get this job done better? So this is where I like to come up with like an abstract ideal solution, right? Like what are my criteria for success? So I say, well, I want to be able to easily onboard these 2 new engineers. Like they should just be able to come in and start shipping code within their first week. I want continuous delivery with transactional updates, which means that instead of like bringing our whole service down and then starting up the new one, I want to make sure that connections are continued to be served while we're starting up the new instances. Automated resource management. So this is scheduling, right? I don't want to have to say, okay, I know I have 3 T2 micros, and I know 2 of them are at 60% CPU, so that means that I can put a service on the 3rd one, and then maybe we'll have to spin up. I don't want to have to do any of that. So what we did was say, okay, we want this to be automated, completely automated, no matter what we do. And then I want to write as little code as possible. Like, I just want to get paid to sit there and have ideas, as everyone does. So maybe 2-3 lines of code a week would be great for infrastructure. And then I can work on product in, like my copious spare time. So this is when we go to analysis and we say, okay, given all the tools that I know about, what are the implementation details of this ideal, wonderful world that I want to live in? So I started thinking about continuous delivery, because this to me is like the hardest problem that we all end up rebuilding over and over again. And I was like, okay, well, there's this thing I heard about called Docker, and apparently it's like super awesome. So I decided to use Docker, right? Because the thing about Docker is it's asset pipeline. Like, you just package all your containers together and you say this is how they interact, and then you can compose them in namespaces arbitrarily. And Docker makes all of this really easy. And it means I don't have to write any Chef, which I'm sorry, Chef people. I've written a lot of Chef. I don't want to write any more like infrastructure code. It's really tiring. So yeah, like, shell scripts to configure my thing, and then it just gets packaged into a little thing, and then it goes somewhere and it runs. That's great. I want to do that. So since we decided to do containers, and we're on AWS, and we want to run our own AWS infrastructure so that we can dog food, we're like, okay, well, I want to run CoreOS. So we chose CoreOS because it's kind of like an operating system as a service, right? You just sort of spin up a CoreOS AMI, and then you can like launch things to it, and it reboots itself, and it coordinates all of its system upgrades for you, and you don't have to do anything. And because we're doing containers, we don't have to worry about all that like system level package management nonsense, where you're like, yeah, I'm just going to cron apt-get upgrade every night at midnight, and it's going to be fine. So we don't have to do any of that, and CoreOS just updates itself. So yeah, and I mean, greenfielding is fun, right? Like, we picked some real shiny CoreOS and Docker. And I mean, it's mature shiny, right? Like, these things have been around for a little while, and everybody's like, yeah, they're awesome, try them. So we picked shiny because we're a startup, and we're gonna greenfield. And greenfielding is fun. I mean, just look at that greenfielding cat. Like, if a cat can be happier, I don't know what it would be doing. I think this is the ultimate cat happiness. So the problem with greenfielding, though, is you're like, okay, wait, we can use everything shiny. Like, we can make this as shiny as possible. So obviously, let's rub some Kubernetes on it. Like, why not? Let's do it all. And I had a free weekend, so I was like, okay, I'm gonna spin up a Kubernetes cluster. Like, Kelsey Hightower, I love this guy. He put together all of this amazing documentation about like getting up and running with Kubernetes. I think that's the name of his book. I can't remember. Kubernetes Up and Running, yeah. And so, we keep in mind our criteria for success. Kubernetes gets us a lot of that. So I decided to just do it. And I'm still super jazzed about Kubernetes too, by the way. So who's Kelsey Hightower, right? I mean, I'm sure just about everybody knows, but just in case anybody doesn't. So I'd have to say he's one of the most prolific speakers on Kubernetes that there is. Not only that, but I think he's like a shining example of what an advocate is, like a developer advocate. This is like the guy who, when I like rage tweet about CoreOS and Kubernetes, it's like, hey, I've got like, it's Friday at 6 o'clock. I've got like an hour. Why don't we do a Google Hangout? And I was like, whoa, okay, thanks. So yeah, it was cool. Oh, and I have a really cool Kelsey Hightower story that I want to tell you too, another one. Real quick, it's super fast. So the first time I met Kelsey Hightower, I was with my best friend Faye, and we were going to a Docker meetup. And it was the first San Francisco meetup I ever went to, my first meetup at all. And Kelsey Hightower, of course, is furiously, frantically preparing for his live demo that he's doing in 5 minutes, right? He's scripting the whole thing. He hasn't prepared at all. And Faye and I go up to him because we're like, oh my God, it's Kelsey Hightower. And we're like, hey, Kelsey, how's it going? Oh my God, we're so excited about CoreOS and Docker. And he's super nice, right? But he's heads down, not looking at us. And he's like, oh yeah, that's great. And so we keep talking to him for a second, and then all of a sudden it dawns on me, and I'm like, oh my God, he's talking in literally 3 minutes. I was like, Faye, let's go, come on, let's get out of here. We're just bugging him. But the point is, he was still super friendly the whole time. So why don't we want to be like Kelsey Hightower? Because he's a freaking champion. When Kelsey Hightower gets a trophy for being awesome, it has a cat on top, and a really happy cat too. And he makes everything he does look super easy and flawless. So it's just, why can't we all just be Kelsey Hightower? Why can't our job just be making how-tos, and that's what infrastructure is like? So, what am I thinking, really? So this, by the way, is Kelsey Hightower sitting in front of his computer. And that IAMS bag is my latest rage tweet storm about etcd. And that's the face he makes when I do that. He doesn't like it. So like most tools, Kubernetes does its job really well if you know what you're doing. And the corollary to that, of course, is that if you don't know what you're doing, Kubernetes is really overwhelming. And needless to say, I got Kubernetes up and running, and I had something deployed, and it was terrifying, so I abandoned it. And that's the end of my Kelsey Hightower stories, really. OK, so now we move on to synthesis, back to Bloom's taxonomy. And with our little Kubernetes experiment finished, we decided to actually build something. So we put together something as quickly as possible, basically just using out-of-the-box CoreOS components. We used Fleet instead of Kubernetes because it has really basic resource scheduling. You just launch a service with Fleet, and it spins up a systemd unit on a first node that says that it can run it, and it has some reasonable conflict resolution. And you can just get things up and running really quickly. And deploys were pretty simple. You just restart the service, and it downloads the latest image from Docker Hub or wherever you're hosting it, and then you deploy it. It's really nice and easy. So that was version 1 of what we built, of course, right? So the next thing we wanted to do is focus on repeatable automated builds, because our build process was not super awesome at the time. So we came up with these 2 containers, basically. We build everything in Clojure and Go because we're super hipster. And we wanted to be able to make sure that everybody locally was building in the exact same environment as they were in CI, and the same environment that we do in production, et cetera. So we built a couple of containers, of course, as one does, to build your containers. So we have containers building containers, and we're like, OK, this might be really slow. And fortunately, Jeff Program and Glider Labs produce this nice little container for Alpine Linux, which is super lightweight. And then there's libmusl, which is this really nice little C library, libc, that you can use. And you get these really tiny, compact containers that you can still have shells in, because some of us are really afraid of running containers in production without shells, so we can get in and poke around a little bit. So yeah, we use an Alpine Linux. We have very small deployables. Most of them are anywhere between 8 and 32 megabytes. And that's the Java one, right? It's huge. So for continuous integration, we decided to do Circle CI. Circle CI is really great because it gives us Docker, and I don't have to build anything, of course. And we get webhooks and a really nice integration with GitHub. So it was good. It was nice. We ended up actually ditching Fleet, by the way, which is why this diagram says ECS. Fleet had its problems. I think that CoreOS has kind of moved away from Fleet to focus on Kubernetes, which is great. That's good. But yeah, we didn't really like Fleet. It was you had to SSH in order to deploy something, and then you'd restart your service, and it's yeah, you have continuous delivery as long as you're OK with continuous downtime. And so we decided to not do fleet, basically. So yeah, we push to GitHub, and on merge to master, we then run circle CI. If build passes, an artifact is pushed to key.io, which is just a Docker repository. And then what happens is we have a little Ansible that starts up a new ECS task. And then ECS says, OK, I have a new task. I'll start the requisite number of services that you want. And then when those come up and they're part of the ELB, I'll take down the old ones, doing connection draining. It's really nice. This is like the exact thing I wanted for transactional updates. And then all of this, like every step of the way, we have feedback going back to Slack so that developers don't have to look at the console for all of this. It's like, chat ops. It's really nice. But yeah, like if anything fails, they get a little notice in Slack, and it's like, OK, cool, I know what to do. So this is all totally easy, right? Like, it took minutes. It was fine. No, everything is super difficult, as it turns out, right? Otherwise, we wouldn't have jobs. So one of the big problems with doing things that I've never done before is that ignorance begets frustration. So everybody here, I think, has experienced new user syndrome. This is where you're like, OK, I'm going to stand up, I don't know, Zookeeper for the first time, right? Like, this is going to be awesome. Or I'm going to stand up Kafka for the first time, or RabbitMQ. Like, and you start it, and you're like, oh my God, what crazy people wrote this software? I don't even understand. I can't even get this to start. Like, I copied and pasted the config file from the GitHub README, and it's not working. So, way to keep your documentation updated, I guess. So, for me, it was etcd, right? And again, like, we're all familiar with Dunning-Kruger and imposter syndrome, right? I think etcd has made me feel worse than, like, my mom and dad ever did. Like, it's really hard, like, OK, so think about CoreOS, right? With the typical base AMI, everything's on root, including like your raft logs for etcd and your Docker, like varlib Docker, where all your containers and images live. So just imagine that, like, you're just starting out and you're like, I don't need to clean up my Docker images. It's going to be fine. I'll just let it fill up the disk. And then we'll reboot, right? Or something. I don't know. We'll just rmrf Docker and reboot. And, well, so the problem with this is, of course, you've only set up like a 3-node CoreOS cluster with a 3-node raft quorum for etcd, and then one of the nodes dies, and then all of a sudden you're like, why is Fleet not responding? And you don't even remember that, like, these were the constraints that you set yourself up with. You're just like, why is everything suddenly broken? But it is. And yeah, so this one time at CoreOS camp, I totally hosed my etcd cluster. It wasn't fun. Like, not only was CoreOS using etcd to handle reboot orchestration and all this stuff, but we were using it for service discovery. We had a little bit of like fake customer data that was in there that would eventually be production data. And yeah, it was a total disaster. And yeah, we learned etcd the hard way. And I thought that it would be like rainbows with unicorns and kittens floating across it because it's all super new technology. And new technology means better, right? This is what we learned from Windows NT. So judgmental cat is super judgmental because I made a lot of assumptions. And then I just was like, it's going to be fine. Everything's going to be fine. I'm going to forget all about best practices. I'm going to forget about 15 years of experience knowing that nothing is ever fine. And I'm just going to run with it. Scissors, just scissors everywhere. I'm going to run all over the place. I'm going to tape scissors to every inch of my body. So, but for real, like we learned mistakes along the way, right? So varlib Docker ended up in an ephemeral volume, EBS volume on all of our instances. So if it filled up, we literally did just reboot and everything was fine. We moved etcd off. We have 3 nodes. All they do is etcd. That's all. Just etcd, nothing else. Nothing can touch them. And that's worked out really well for us. And yeah, so you learn from these little bits and you fix them. Like the big thing is don't let them become technical debt, right? As you're going along and you're learning how to do new things, just don't continuously accrue technical debt like we did. So yeah. This was our report card that we made in the beginning. Easily onboarding new engineers. I think we did pretty well. We talked to Mark, who is one of our 2 new engineers that we hired, and he says, my biggest obstacle was understanding CoreOS and reconciling some faulty assumptions, but I kind of put that off until last week. And he's been here for like 2 months, and he has 3 services running, and he's not even had to think about how we did things. So to me, that's an A+, because I set this stuff up, and I kind of got it working, and then he came along and was able to be productive. And that, those are feels, right? He's since then also gone on to take over all the infrastructure and make it way better. So that's also nice. Continuous delivery with transactional updates. I'm super excited about EC2 Container Service, by the way. If you haven't checked out ECS, definitely do if you're in AWS. It made our lives a lot simpler. We looked at Kubernetes, obviously, because I really like Kubernetes. Oh, sorry. It's a really powerful abstraction. It allows you to do all of the resource management with the full Docker API really easily. And the problem is, though, that it's very management intense, right? Like there are multiple services. It's not OpenStack, right? But it's Kubernetes. And so you have like a few services as opposed to like 150 services that keep your infrastructure running. But I mean, ultimately, we only had 2 services, and we'd have to have 3 services just for infrastructure, and it didn't make sense. And again, like I just didn't want to automate anything. Like I guess if there's anything I took away from this whole experience, it was like just buy everything. Don't build anything, really. You're just setting yourself up for problems, I'm telling you. But yeah, so ECS also gives us really nice automated resource management because you do declarative resource scheduling. You say, this is going to take up X amount of RAM. This is going to take up X amount of CPU. And then if it tries to take up more, it just dies. And I like that fail-fast philosophy because it's like, oh, wow, this is spiraling out of control. We gave this 512 megs of RAM to start with, and then we gave it a gig, and it's still just using more. That's probably a memory leak because it starts up and it only uses 112. So yeah. And for writing as little code as possible, like literally for infrastructure, all we wrote is some Ansible YAML files and a couple of plugins. All of the AWS stuff that we manage is there in Ansible, and we didn't have to write any of it. And all of the ECS stuff was there, and we just had to write a little bit around continuous delivery, which is fine with me. So besides going back and like evaluating the thing that we built, we also need to make sure we take away a lot of lessons from this, right? So just say no to copy and paste infrastructure. The biggest thing that I have done myself and that I've seen other people do is you go in and you're like, oh, I want to try this new thing. And you go to the tutorial and you do the tutorial and then you build your infrastructure on top of the result of that tutorial. Like at one of my previous jobs, we ran Sensu for monitoring, and like the little tutorial thing for SSL cert management was like literally checked into Git so that we could manage certificates. And I was like, no, we're not going to do that anymore. So yeah, just don't start from how-tos. Like you can use it if you just want to check something out, but build something real and meaningful from the ground up and understand every decision that you're making. CoreOS is a Linux container hypervisor. That's the way I'm starting to think of it now. It is not like a super distribution like Ubuntu. If you start using CoreOS, expect to have difficulties because you're coming from something that lets you do literally anything and was meant basically to be a desktop operating system. And you're going to something that was not even meant for you to log in. And yeah, so CoreOS, Docker, ECS, tons of infrastructure code that we did not have to write. And I think that working on product all the time has kind of, I love working on product. Like it's a lot of fun. And so like the whole embedded model of DevOps is really cool because you get to work closely with the people that are building the product. And so I find myself now thinking, oh, well, product is way more fun. I just don't want to build ops stuff. Like let's let other people dedicate themselves to that. And that's it, basically. That's why I heart Kelsey Hightower, why I heart DevOpsDays and you and everything in my job. And yeah, so thanks.